Hello everyone, my name is Vijayas, studying BE in Sri Venkateswara College of Engineering in section DO, roll number 23CA1694, subject Principles of Programming using C, subject code BPOPS103D. Exploring nested for loops with example. Here in this video, I am going to explain about what is nested loop, where and when they are used with example. Before we discuss about the nested loop, first we need to know what is loops. What are loops? Loops are a programming element that repeat a portion of code a set number of times until the desired process is complete. In other words, we can say that a loop is a sequence of instructions that is continually repeated until a certain condition is reached. If we have to perform a program using loops, we need to apply certain conditions in it. If the first condition is true, then the program is executed. If it is not true, then the second condition is executed or the program will get end. Now coming to the main topic of the video, nested for loops. Understanding nested for loops. Nested for loops consist of an outer loop and an inner loop. The outer loop controls the number of iterations, while the inner loop is executed for each iteration of the outer loop. We will demonstrate how to use nested for loops to generate prime numbers. Before we discuss about the nested loop used in prime numbers, I will show the flowchart how the nested loops are used in a program. This is the flowchart for nested loop. Now I am going to explain about this flowchart. Before we start the program, we need to give initialization. It means input or hash include with library functions. Then we have to give certain conditions to execute the program. Then we give condition 1 and condition 2. If first condition is true, then it will go to check condition 2. If first condition is itself false, then the program is not executed. It ends the program. If first condition is true, then it goes to second condition. Then if second condition is false, then the program is ended with condition 1 is true and condition 2 is false. If both the conditions are true with increment or decrement, then it is executed with some statements or input or output statements. This is how nested for loops is used in a program. Now I will give some one example how it is used in a program. Algorithm for finding prime numbers. To find prime numbers within a range, we will utilize a nested for loop structure. For each number in the range, we will use a nested loop to check if it is divisible by any number other than 1 and itself. This process will help us identify prime number efficiently. Now we will see the example. Example for program to print numbers within a given range from 1 to n using nested loop. Now we can start the program. Hash include stdio.h. This is called the initialization of any program, where it starts from hash include and with it is included with some library functions like stdio.h, conio.h or mathio.h. Void main. This is a empty where it does not contain any like it does not contain anything or it returns the value again back. Next int is prime int num. Now we are finding the prime number. So we are giving the value as prime with integer and int num. Open brace if num less than or equal to 1. First we have to find the prime number 0 which it is prime number or not. So we will give num less than or equal to 1. Open the bracket, return 0 because 0 and 1 are not a prime number because we have given firstly the condition as less than or equal to 0. Here we will get the numbers only 0 and 1 which are satisfied. So 0 and 1 are not a prime number. We will close the brace. Now we will check for other numbers. For int I is equal to 2, I into I is less than or equal to num I plus plus. Now int I is equal to 2. Now we got to know the 0 and 1 are not a prime number. Now next 2, I is equal to 2, where I plus plus is called increment, where 2 plus 1, it checks first 2, then 3, then next numbers. Open the brace. If num modulus I is equal to 0. Modulus means it gives the answer as a reminder. Example 4 divided by 2. The modulus of 4 divided by 2 is 0, which is a reminder. Now opening the brace. Now return 0 is not a prime number. Where it checks the condition. If it is false, then it returns 0 and it is not a prime number. Close brace, close brace. Next return 1. If the condition is true and executed, it returns 1, then it is a prime number. Close brace, int main, open brace, int n. This is a data type given for a prime number because it is an integer. Input the range n from the user. I am the user. I am the inputting the program from the range 1 to n. We are finding the program of prime numbers from the range 1 to n. Printf. This is an input function where we are inputting the values. Enter the value of n. We need to give the value for n. So enter the value of n. Scanf. This is called output function. Modulus d comma star n. We need to give the value for n. So it asks the value of n. Printf. This is an input function. Print numbers from 1 to modulus d are n, n. We are checking the program from the range 1 to n. So it asks the input from 1 to n. Nested loop to check and print prime numbers within the given range. This is the condition for program. Next, for int I is equal to 1, I is less than or equal to n, I plus plus. I plus plus, it increments the values. If I is 1, then it increments by plus 1. I is equal to 2, 3, 4, so on. If is prime I, open brace, printf inputs the value of I modulus d, where we input from 0 to 1, 2, 3, n integer. Integer states that from 0 to 1, every whole number and natural number. Printf, we are giving the value for I. Close brace, return 0. If it is not prime number, it returns 0, which is false. Close the brace. If it is true, it returns 1 and it gives the output as it is a prime number. Now we will see output for this video. We are enter the range, the prime numbers from the range 1 to 10. We get the output as 2 is a prime, 3 is a prime, 5 is a prime, and 7 is a prime. Now coming to conclusion part. Conclusion, mastering nested loops. Nested for loops are a powerful tool for iterating through multi-dimensional data and solving complex problems. Through this exploration, we have learned how to use nested loop to efficiently identify and print prime numbers within a given range. Thank you friends for watching my video. If my content was good, share and like the video.